Hello all, my name is Ashutosh Rastogi. I am a teacher by profession. My mission is to impart quality education for all. For that purpose, I am creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos. Anyways, today in this particular lecture, we will try to give you a brief overview about the pulse modulation systems. These are the outlines of today's lecture. We will start up with the introduction. Then we will try to discuss in brief about what is the need of pulse modulation systems, especially when we have our analog modulation systems such as your amplitude modulation and angle modulation schemes. Then classification of pulse modulation system, in which we will discuss about analog pulse modulation and digital pulse modulation. Then we will discuss about the pulse amplitude modulation, in which we will briefly describe what is the basic definition of pulse amplitude modulation. Then we will discuss about pulse width modulation, which is also known as your pulse duration modulation or pulse length modulation, which will be followed by your pulse position modulation. Then finally we will conclude what is the basic definition of pulse code modulation and what pulse code modulation system is. So we will start up with the introduction. We have covered various analog modulation schemes such as our amplitude modulation or angle modulation. We have already discussed that the modulation, we actually vary some of the characteristics of my carrier waveform such as its amplitude, phase or frequency. We will going to vary those characteristics as per the instantaneous amplitude of my message signal. So we have already discussed about our amplitude modulation systems and angle modulation systems. These are basically continuous wave modulation schemes in which we actually transmitting our signal in the form of some continuous wave or analog waves of high frequency. So these continuous wave modulation schemes serve the purpose of the information exchange. Then the major question arises is when we already have those continuous wave modulation schemes, then what is the utility of having another pulse modulation schemes? So here is the answer, which is also the need of the pulse modulation. So in our continuous modulation schemes, carrier signal is continuous in nature. That is, it is present at all the time. What I wanted to say is in our continuous wave modulation schemes, we are transmitting our signal with the continuous carrier waveform, which is generally your high frequency carrier waveform whose amplitude or frequency or phase is being varied as per the instantaneous value of your message signal. But what we try to focus at this particular point is this complete waveform through we will going to transmit our signal is continuous in nature. It means for every instant of time we will be having some amplitude value of my carrier waveform, which makes it continuous in nature. So if in terms of channel capacity, we have limited frequency ranges. I mean, since bandwidth is limited and it is also very scarce resource, so if we want to allow more and more number of users to follow the same spectrum, then in order to increase the capacity of the system, we need to look forward for something else. So what if by any means we can discretize our continuous signal? I mean, we could make it discrete in the time domain and transmit another discrete signal at the place where the first signal is not present. So obviously by doing so, we can enhance or increase the capacity. That is, we can utilize our channel to support more number of users. Obviously, we are talking about to transmit the larger number of users data over the common medium where the signal of first user is not present. So that simply serves a purpose that will going to increase the capacity of the system. But provided we have the capability to convert our analog signal to the discrete signal at the transmitting side, and obviously to convert our discrete signal to the analog signal at the receiving side without having any substantial loss in the information signal. Obviously, if there occurs certain amount of losses, so there will be the loss of information and your communication system is of no use if we will getting certain faulty information. So obviously we have the capability to do so, then that can completely serve the purpose. it provides the basis for another multiplexing schemes, that is your time division multiplexing. So this might be the major reason why we actually move forward for our pulse communication system over our analog continuous wave modulation systems. So now next question is, what is the pulse modulation? So before we will define what is pulse modulation, let us discuss what are the various parameters by which we can characterize a pulse, as we have already discussed that in our continuous wave modulation systems, any continuous wave could be characterized by three parameters, that is its amplitude, its frequency and its phase. In a similar manner, if we want to characterize a particular pulse, then we should have the information about its amplitude, its width and its position. If we know these values, then we can characterize any of the pulse. So in pulse modulation systems, some of the parameters of our pulse terrain is varied in accordance with the message signal. Obviously, here our carrier wave is not continuous, it is pulsating or in the form of pulse train. So pulse modulation is the process of transmitting signals in the form of pulses by using certain special techniques. As we know that our information source is generally generating our analog signal. So let us say this is your information signal generated by your information source, which is analog in nature. So some of the waveform of various pulse modulated signals will be likewise your pulse amplitude modulation. What we will going to do is in amplitude of my carrier pulse will going to vary as per the instantaneous amplitude variation of my message signal, as we can see in this particular figure. As our message signal's amplitude is increasing, the pulse amplitude is also increasing, and as the amplitude of our message signal is decreasing, the amplitude of my carrier pulse train is also decreasing. So this will keep continuing. So the typical waveform of pulse amplitude modulated waveform will be look like this one. Then pulse width modulation, obviously the width of the pulse of our carrier pulse is being varied as per the instantaneous amplitude variation in my message signal. So here we can see that the width of the carrier pulse is actually being increasing or decreasing as per the amplitude increment or decrement in our message signal. So here in this particular waveform, the position of carrier pulse is being varied as per the amplitude variation of my message signal. On close observation of this particular figure, we can observe that this particular waveform of our pulse position modulation system is actually follows our pulse width modulation systems. At this particular position, the pulse width modulation has been started, and at this particular position it is actually moving down. Then again at this particular instant it is increasing or moving up, and at this particular instant it is moving down. So it is actually following our pulse width modulation. This particular figure shows about pulse code modulation systems, in which we actually transmitting our pulse in the form of coded pulses. The next is classification of pulse modulation. So we could actually classify our pulse modulation systems into two parts. Number one is your analog pulse modulation systems, and second one is your digital pulse modulation systems. You could further classify our analog pulse modulation systems into pulse amplitude modulation systems, pulse width modulation systems, and your pulse position modulation systems. Whereas the various classification of digital pulse modulation systems is being given as: first one is your pulse code modulation system, another one is your delta modulation. There are other digital pulse modulation schemes such as your adaptive delta modulation, differential pulse code modulation systems, etc. But we will discuss only about your PAM, PWM, PPM and the PCMs. About other digital pulse modulation schemes we will be studying in upcoming lectures. So we will start up with the pulse amplitude modulation. So what is pulse amplitude modulation? In this particular type of pulse modulation, obviously the width of and timing of the pulse is remained constant, and we actually maintain its constant, but the amplitude of each pulse is being varied in accordance with the instantaneous value of the analog signal. Why we always take the amplitude of the analog signal? Just because the information contained in any of the signal is being directly proportional to its amplitude. We had already said that as a communication engineer, we have to deal with the energy signals or power signals, and the energy or power of any signal is being easily characterized by the amplitude of the signal. So we always take the amplitude of message signal in order to quantify its information. Sampling theorem actually provides us the basis to convert our analog signal to the discrete time signal. So the signal is sampled at regular intervals such that each sample is proportional to the amplitude of the signal at the sampling instant. I mean, whatever be the amplitude of information signal at the sampling instant, the sample value will going to take that amplitude value. So this particular figure shows the analog signal which is continuous at time. So the waveform of amplitude modulated pulses will be given by this particular figure. Here we can be observed that the instantaneous amplitude of my pulse reflects the information about the instantaneous amplitude of my message signal, or we could say that amplitude of pulses at various instant is being directly proportional to the instantaneous value of my message signal. So this is our amplitude modulated pulses. So next is pulse width modulation, which is also known as your PWM or pulse length modulation or pulse duration modulation. So this type of pulse modulation scheme, the amplitude is maintained constant, but the duration or the length or the width of each pulse is varied in accordance with the instantaneous value of the analog signal. Obviously, another criteria by which we can characterize any pulse is its width or its duration. So we will going to vary this width or duration or length of the instantaneous with respect to the amplitude of the instantaneous amplitude of my message signal. So whatever waveform we will get, this will be the your pulse width modulation waveform. So the negative side of the signal is brought to the positive side by adding a fixed DC voltage. In our last example, we have seen that our analog signal will look like this. There is some positive amplitude value and some negative amplitude value. So initially we will be going to add some DC fixed voltage in order to make it positive. So suppose our waveform is 2 sine omega t. I mean, this is plus 2 and this is your minus 2. So we will going to add plus 2 volt to our signal so that we could make its peak value is plus 4 volt and lowest value is 0 volt. This is what we mean by the negative side of the signal is brought to positive side by adding a fixed DC voltage. So this particular waveform shows our pulse width modulated pulses. So this is again your message signal which is continuous in nature. Then the width of the carrier pulse is being varied as per the instantaneous amplitude of your message signal. Then next is your pulse position modulation system or pulse position modulation. So in this type of pulse modulation, the sampled waveform has fixed amplitude and width, whereas the position of each pulse is varied as per the instantaneous value of the analog signal. So since pulse position modulation signal is further modification of pulse width modulation signal, it has a positive thin pulse corresponding to the starting edge of the pulse width modulation pulse and negative thin pulse according to the ending edge of the pulse. This is your pulse width modulated waveform whose width is being varied as per the instantaneous value of my analog message signal. This particular waveform shows a pulse position modulation or pulse position modulated waveform. So here thin pulses at the starting point of pulse width modulation and at the negative pulse at the falling edge of the pulse width modulation schemes. So now moving forward to our digital pulse modulation schemes, that is your pulse code modulation scheme or pulse code modulation. In pulse code modulation, it is the method that is used to convert an analog signal to the digital signal such that the modified signal can be transmitted through the digital communication networks. PCM is actually the binary form. So we can say that there will be only two possible states, that is high or low. By binary, we mean by 0 or 1, which could be logic high or 0, or we could say that high value of pulse and low value of pulse. There will only two states. Here the pulses of varying width according to the coded sequences is being transmitted on the channel for the information exchange. Obviously, on close observation, we could say that the waveform of pulse width modulation or pulse code modulation are almost the same. But on close observation, we easily demarcate them. In pulse code modulation system, we actually being passing the coded sequence, so the width of the pulse is being directly proportional to the code assigned, so to that the instantaneous value of your message signal. Let us say or suppose that this is our continuous time analog signal. So this particular waveform shows the pulse code modulation system. So initially we have to convert this continuous signal into the digital one, that is a sequence of 010101. Then we will going to generate the pulse depending upon binary values. For 0 it is 0 and for 1 it is high value of pulse, for 0 it is low value of pulse, then again one high value of pulse. So this is the complete sequence of your pulse coded modulation or pulse code modulation. These are the references. Thank you very much for your patient hearing.